All right, today we're going to do P.2. P.2 is Cartesian coordinate system. This obviously is a review. We're continuing with our review. Okay. The Cartesian coordinate system, otherwise known as the rectangular coordinate system, otherwise known as the only coordinate system that you guys have ever learned. All right, that'll change this year. But so far, all you know is the Cartesian coordinate. So Cartesian coordinate, we have the x-axis, we have the y-axis, we have the origin here. What else do I need to know? Is there anything else that we know here? We have learned that we divided these into quadrants, right? We divided these into quadrants. Okay, these are different kind of quadrants. Hunter. What quadrant am I pointing at?
1.
Try again.
Oh, no clue.
Okay. 1, because this is, okay, so we're still looking at this quadrant here. Ethan, what quadrant is this?
Second.
The second quadrant, right? We start from this quadrant, which is the first quadrant. 1, 2, 3, 4. Going counterclockwise. The quadrants are usually notated in Roman numerals. 1, 2, 3, 4. Okay. 1, 2, 3, 4 quadrants, right? Okay. Blah, blah, blah. Let's see. Okay, we're going to skip example 1. All that is plotting stuff, so we're not going to do that. Go to page 13, the top, there is a blue box there. The absolute value of a real number A. Absolute value of A. So the absolute value. Absolute value of A is equal to A if A is greater than 0. If A is less than 0, this becomes negative A. All right? So if this is kind of confusing, what it's saying is here. So if I have -5, so A is -5, the absolute value of -5 is what? Sam?
5.
5, right? It is 5, which means, but 5 is actually what? 5 is, this is the same as -5. In other words, negative of the value, negative A. When A is less than 0, this comes out as negative A, okay? Because the original A itself was negative, so a negative becomes a positive here, okay? Example number 2, evaluate. We did the first one, so we'll skip the first one. The second one says evaluate pi minus 6. Brooklyn, what is this?
Well, pi minus 6 is negative.
Yeah.
So, I don't know.
Correct. So this is about the negative of the original value, correct? Just like we talked about, right? So this is going to be the same as 6 minus pi, which makes sense because pi is 3.14. 6 minus 3.14 now is a positive number. So it came out as the negative of what was inside. That's what this negative here signifies. And if I do the negative times negative, I get a positive. So that's why this is positive 6. 6 minus pi. Okay? Fun question there. Okay, in the middle of page 13, there's the properties of the absolute value. Go ahead and breeze through that. There should be no surprises there. Okay, underneath that, we have the distance formula. The distance formula, okay, this is on a number line. On a number line, the distance between A and B is, this is A, this is B. The distance between these two is going to be B minus A, which incidentally is the same as that, because the order does not matter, because this one's going to be positive, one's going to be negative, but once we put the absolute value on them, they both turn out to be positive, correct? Okay, so on a number line, the distance formula looks like that. On a regular Cartesian coordinate, the distance formula is the one that we are familiar with and we love and we like. We have the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And when we were in algebra 2, we memorized this and we used it very well, okay? In honors algebra, in honors pre-calc, now we have to find out, we have to know the reason behind this. Where did this come from? Okay, so where this comes from is actually, this is a derivative of the Pythagorean theorem, right? So if I have x1, y1 here, and I have x2, y2 here, what I'm looking for is this distance here from here to here, okay? The way I figure this out is that I'm going to try to find, I'm going to try to put a triangle like this. Okay, I'm going to find this side and this side. So this side is y2 minus y1. Okay, so it's the, on the y direction, this is y2 minus y1. In the x direction, since this is the x of this is x2, this is x1. So the difference here is x2 minus x1. Therefore, the Pythagorean theorem says this squared plus this squared is this squared. In other words, the distance that I was looking for, so the distance squared is this guy squared plus this guy squared. And so that is the Pythagorean theorem. So D is going to be that. Well, Mr. Ron, when you do that, aren't you supposed to put plus or minus here? Why do I not use the minus? Anybody? Why do I only write the positive here? Dead silence.
You can't square a negative.
Well, you can always square a negative, all right? You can square -1.
Well,
-1.
if you're not dealing with imaginary numbers, no, you can't.
No, that's not it. The reason why there's no negative here is because we're talking about distance. You cannot have a negative value of distance, correct? So by definition, that's why you cannot use a negative here when we're talking about distance, okay? So page 14, in the middle of page 14, it shows you that equation. So let's go to example number 3, see if we can use that. Find the distance between points 1, 5, and 6, 2. Okay, so the distance between 1, 5 and 6, 2, right? So I'm going to get D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared is equal to, this is 5 squared is 25. This is -3. -3 times -3 is 9. So I had 25 and I had 9, square root of 34. Okay? What happens if I call, so in this instance, I call this guy x1, y1, this guy x2, y2. What if we switch it around? If I switch it around, what do I get? I get, if this was x1, x2, no, and x1, y1, this is x2, y2, then I would have what? 1 minus 6 squared plus 5 minus 2 squared. You have minus 5 times minus 5, which is 25 again. 3 times 3 is 9. 34. In other words, it doesn't matter whether I put this guy as x1, y1 or this guy as x1, y1, all right? As long as I keep them correct, all right? Either one of them's x1, y1, the other one, I mean x1, y1, the other one's x2, y2, it should come out the same. Okay? Midpoint formulas. Okay, the midpoint formula of a segment is nothing more than a plus b divided by 2. Okay? Midpoint formula in a coordinate plane is what? If I had A, B, and C, D, A, B, point, C, D, the midpoint formula is I add the two x's together, divide by 2, add the two y's together and divide by 2, and this here is going to be my midpoint. Okay, this is my midpoint, right? Way that this gets developed, if you want to look at it, is let's say that we had, again, 2 points here, and this was what? A, B, this guy was C, D. So what we're trying to find here is the midpoint right here, right? Okay. So this is the midpoint between this point and this point, correct? So this is A, this guy here is A, the X is A. The X over here is what? C, right? So it's the middle between A and C. So the X coordinate here is going to be A plus C divided by 2, all right? And on the Y, same thing. Okay, this guy here is the midpoint between this guy and this guy. This guy was D, the Y coordinate here is D. The Y coordinate of this is B. So it's going to be B plus D divided by 2. Okay, and that's where the midpoint formula comes from. All right. Are there any questions of what we talked about so far? If there are no questions, I'm going to go ahead and have you guys start on the homework.